Temperature surveys measure the difference between the fluid temperature within the casing and the geothermal gradient, and are used to locate fluid entries in producing wells and fluid exits in injection wells. For example, liquid flowing into the wellbore from the formation enters the wellbore at essentially the same temperature as the formation. As the liquid moves uphole, its temperature gradually begins to decrease as it loses heat to the surrounding cooler formations, approaching the geothermal gradient. In general, this geothermal gradient will be displaced to the right as the flow rate increases. Looking at gas entry for the same completion geometry reveals that the point of gas entry shows a cooling effect due to the expansion of the gas. As the gas moves uphole, it is heated until it crosses the geothermal gradient and begins to cool above that point. The magnitude of the entry point cooling effect depends on the pressure drop, which in turn depends on the gas flow rate and the formation permeability. Lower pressure drops will give less of an effect. The temperature log, when run with other surveys such as the flow meter and a fluid identification device, may also be effective at detecting channels behind pipe. In our example, produced fluid is being supplied up a channel, below the casing perforation. Since the static fluid below the perforation is in thermal equilibrium with the produced fluid in the channel, the temperature survey will indicate a fluid entry here. The accompanying flow meter will indicate a fluid entry here. The discrepancy is explained as follows. Since the temperature log detects changes both inside and outside the casing, it shows the actual depth of entry from the formation. The flow meter detects fluid movement only inside the casing, so it shows where fluid is entering the wellbore at the perforation. Based on these facts, a behind-pipe channel is a reasonable explanation for the conflicting information. In the case of a channel above the perforation point, the flow meter again shows the entry point into the wellbore. The temperature survey indicates cooling there and suggests a gas entry. But the temperature survey also indicates another point of cooling. When the fluid identification device confirms that the produced fluid is a liquid, the confusion is explained as a channel from above. Temperature surveys are also used in injection wells to identify the intervals taking fluid. The technique entails running a pre-injection base survey, running a temperature survey while injecting the cooler surface liquid, shutting in the well, and then running a number of temperature surveys during shut-in. The volume of injection fluid left in the wellbore after shut-in will return to the geothermal temperature relatively rapidly, while the large volume of injected fluid held in the zone of injection will warm to the geothermal temperature much more slowly. As a result, the shut-in temperature surveys develop a bump across the injection zone, highlighting its extent.